So this first question, displacement in centimeters of a particle from origin O time. So we've got the displacement graph. And from the displacement graph here, I want to find the maximum distance. So put that in the calculator and see what we can get. A new graphs page, control add page, graphs. Number 2, make sure in radians because this is a trig question. And we'll do x squared multiplied by, always put a multiplication after a letter before trig or brackets, cosine x plus 2x multiplied by sine x. And there's our graph. We want to go between 0 and 5 in the x values. So 0 there. Maybe I'll take that up to 10 to see it. And then this only goes to 5. Let's go to negative 20 to see everything. Well, it looks like here's my maximum here, but it's wants the maximum distance. So that's the distance. This is also distance, looks much bigger. Let's just check. This looks a bit obvious. Analyze the graph, look for a maximum number 3. Click to the left of the maximum and then go across to the right, and we've got the maximum there. And I'll do a minimum 2. Analyze minimum number 2. Start to the left of the minimum and go to the right of the minimum. I've got a minimum, so this is my value here. If I hold my cursor over it and then do plus, I can see more detail, or negative, and it will give it to me round to 3 significant figures, which isn't actually difficult to do, but just in case. And I've got the maximum distance. So we have a graph a bit like this. And the displacement looks like this. Oops, not quite like that. Looks like this. And that's between 0 and 5, which is what it wants. And the maximum distance, well, this is 3.1534. And this is 16.51309. This is y equals s of t. This is t. So I marked what I've done. So part A, maximum displacement is negative 16.51309 ... which is approximately equal to negative 16.5 to 3 significant figures. Now we go to part B. Find the acceleration of the particle at the instant it first changes direction. So it's going to change direction is when the velocity goes to 0. So let's do a velocity graph. So now we need a velocity graph and put that in the calculator. And this is displacement. So to find our acceleration, let's do a new graph of the velocity. I could do an acceleration graph, but I'm going to do velocity just to see what that looks like. It's probably easier. So click on this button to get differential d by dx of f1. So we'll do variable f1 of x. And that gives me, this is now the velocity graph, and it says when it changes direction, in other words, this is positive to negative, this is negative to positive, so it changes direction there, changes direction there. So I actually want this point here. Let's put a point on, menu, geometry, points and lines, point on number 2. Put a point on here somewhere. Escape from adding on points and change this to a 0 here, so it's exactly where it crosses the axis. We want that point there. And now on the acceleration, well, that's the differential, the gradient of this one, the differential of this one. So I'm going to do menu, analyze graph, differential number 5. And which graph do I want? I want the red one. And point on, so we do it there. And it said, you can see that. Undefined. That's not good. Let's try that again. Let's take this value here and store that variable. So over there and store the variable and call it change direction 1, x. That's the first change direction. Let's go to a calculator page, add a calculator page, and let's do the differential menu. And I want algebra, we want calculus, numerical derivative for a point, variable x, value is at the variable. Let's put 3 in for the moment, we can change that later. Change it to second derivative, so I get the acceleration. And we want the second derivative of f1. We could do the first derivative of f1. And this x value is actually at change direction 1 point. And it gives us the acceleration at that point. So our velocity graph looks like this. So this is y equals vt, which is s dash t, so they know what I've done. And change direction, so I have this point here is 1.5199, 0. And this point, so that's when it first changes direction, that's what I want. So we want a equal a of t, a of 1.5199 dot, which is s double dashed of 1.5199 triple dot, which is, put that in the calculator, see what we get, negative 8.919409, which is approximately equal to negative 8.91. And this is in meters per second per second. And this is in meters, I should put in meters there.